Hello everyone, welcome to this lecture on NumPy in Python. So this popular Python library, it is used for numerical operations. We can apply various arithmetic operations on arrays, and we'll first create an array using this NumPy package, and then we'll discuss all operations that can be performed on it, and also various functions available in this NumPy library. We'll discuss everything in this lecture. So it stands for numerical Python. It was created in 2005 by Travis Oliphant. It is an open source project, and this library is widely used for working with arrays. It has several functions. We can also implement this NumPy array for linear algebra and Fourier transform, and also we can work with matrices, multidimensional arrays, using various functions available in it. We can also perform various scientific computing tasks in Python. It provides a support for working with a large amount of data as well. And we go for this NumPy because it stores the elements in a contiguous memory locations. It is faster than list. The list can contain different types of data, but NumPy array contains elements of the same type, but it can it can be used to work with large sequences. We can also utilize this ND array feature, so we can create an array object in NumPy. So it is called ND array. It provides a lot of supporting functions to work with the array, and it improves the speed compared to the list. This is faster, and also it is less flexible because we do operations element wise. So addition, subtraction, addition, and deletion operations will take mm, uh, more effort than list. In list we can apply additions and deletion easily. Now let us discuss why this is faster. Since the elements are stored in contiguous memory locations, we can easily process them and access the elements more efficiently. And this concept is called locality of reference in computer science. The main reason for going for this NumPy array is that it is faster than list, and it is optimized to work with the latest CPU architectures. And we have ND array object to work with multidimensional objects, multidimensional data. It encapsulates dimensional arrays of homogeneous data types, and it allows more efficient storage and manipulation of large data sets. First, we have to install this NumPy if it is not there already in the Python environment. So, if to install this, we use pip command, pip install NumPy from the command prompt. From the another command prompt, we can try this command to install this. Once installed, we can import this using import command. We can import this NumPy library, and then we can create a NumPy array. So this left hand side is a NumPy array name, and right hand side will be call this array function, and we pass this list that contains list of 5 items. So it creates an array with these 5 elements. This code will be all these 5 elements. So this is an one-dimensional array, and we can also create multi-dimensional arrays. We can apply various operations in it. The arrays can be created in several ways. So first, let us now create an array using this list. So this contains 5 elements. The second array we created with the 5 elements, but here we applied the concept of tuple. So the list is mutable, but array that contains tuple is immutable. And then we will move on to creating the arrays with zeros elements of different sizes. Now we call this zeros functions using np shorthand name of numpy package. So we are specifying two dimensions, 3 by 4, that is 3 rows and 4 columns of zeros elements. So it will be having 12 zeros elements. And then next we create an array of size 6, that is 2 cross 3 matrix we create with all ones in that array. So the next one is empty array. Here we have created a 2 by 3 2 by 2 array with uninitialized values. We also have a function called arrange to display evenly spaced integers. For example, here we start with 0 and go up to 10, but the numbers should be printed evenly uh, with the 2, that is 0 1 2 and then 4 and then 6 and then 8. So it prints the elements with a difference of 2. And then we also apply linspace function to create a array that represents elements in a linear fashion. So we are printing only 5 elements starting with 0 and going up to 1. We print these elements in a linear space. Then we'll discuss in detail about attributes that can be used with this NumPy array. The attributes are properties of array objects. It provides information about the arrays and the data, and we can access various part of an array, and also we can modify them easily using the attributes. We can understand the type of the data and the number of data items and so on. So we'll discuss all these attributes now. First, let us start with the shape attribute. This shape attribute is used to display the dimension of the array. We can also resize the array, that is, we can reshape the array by modifying the size of the array. For example, in this example we are retrieving the shape of numpy array using the shape attribute. So this contains 1 2 3 in the first row and 4 5 6 in the second row. So we have 2 cross 3 array, and the shape of this array is 2 rows 3 columns. So this resize operation, we specify the dimension on the right hand side as in a tuple form. 3 by 2 is a actual dimension, so 3 rows 2 columns. So this gets stored in the shape variable. So we are accessing the shape of this using a dot shape, and we are printing the variable a. It stores it has stored the dimension. We can also use this reshape function to change the size of an array. So in this array we can see we have modified the size by having 3 rows and 2 columns. So we have applied reshape function for this, and then we are printing the result. So the resultant matrix or array contains 3 rows and 2 columns. The next attribute is ndim attribute. So this attribute returns the number of dimensions of an array. This is more efficient to determine the dimensionality of an array. We can access this using array variable dot operator and then specifying this attribute. So first we created an array 1 with these 5 numbers, this one dimensional array, so the dimension is 1. Next we are creating a 2-dimensional array. The size of the array is 2 cross 3, so it contains 0 elements. All elements of this array would be 0, so the dimension is 2 dimension. The array has size limitations based on the amount of memory available in your computer. So there is no strict limitation on the number of dimensions, but there is a practical constraints in it. So the maximum number of maximum size of an array is determined by the platform and Python's integer type. For example, it can have maximum of 2 power 3 and 2 power 31 minus 1 elements for a single array in most of the systems. And if there is a large number of dimensions or elements, it may cause memory error. We have a arrange attribute. It is used to print numbers, uh, evenly displayed numbers. Sequentially, we have printed a number starting with 0 to 20. So the number of the number given is 21. So it starts with 0 and goes up to 20. The numbers are evenly spaced numbers. And then the next attribute is size attribute. It returns the total number of elements in the array. For a one-dimensional array, the size is the number of elements in the array. For a two-dimensional array, we will multiply the number of rows and columns. So for a three-dimensional array, the size of the array would be the product of size of all 3 dimensions. So in this example, we have an array with 2 rows and 2 columns. So the size would be 2 cross 2, that is 4. The number of elements in the array would be 4 elements. The next attribute is dtype attribute. It is used to identify the type of data that gets stored. So in this array we have integers. So array1.t type will print int 64 by default. By default it follows 64-bit integers type. So for each element it allocates 8 bytes in memory. The next attribute is item size attribute. So first we have created 1D array of integers, and then this 1D array of 32-bit integers will be printed, and the data type of this is integer 32-bit. So for each element it allocates 4 bytes in memory. And then the next one is 2-dimensional array. The first one is array 1 is 1-dimensional array of integers. The second one is 1-dimensional array of 32-bit integers. So for the first one, it allocates by default 8 bytes for each element in the array, and for the second one it allocates 4 bytes only, because we have specified explicitly that it is a integer 32-bit type. So that's why it is allocating 4 bytes for each element. So the item size is 4 bytes here. So for array 1, each element takes 8 bytes in memory. The next attribute is data attribute. So this attribute is used to get a buffer containing actual elements of the array in memory, and it displays the memory address of the element, and it acts like a pointer to the memory location where the array's data is stored in computer memory. So the array 1 contains 3 elements, and array 2 contains 2 cross 3 matrix. So we are printing the memory address of array 1 and array 2. So the first array address is printed over here, memory address of array 1 is printed over here, and then the memory address of the second one is printed over here. So it returns the memory address of the data for each array. The next attribute is base attribute. This returns the base object if the array is having a view on another array. So if the array contains its own data, then the base is to be set as none in NumPy. So this array base refers to the original array from which a new array is derived. So in this example, we have first created our original array that contains 2 cross 3 size, and then we are creating a view that is a slice of the original array, taking elements starting from 0 to 1, all elements start to n. So this will be forming a 2 by 2 matrix, but we are accessing the base array, that is original array. Using this view array variable, we are accessing the base attribute, so this will display the original array. So it refers to the original array. So that's all in this lecture. We have discussed what is NumPy, why we use NumPy, and what are all the operations we can perform with NumPy array, and also we have discussed in detail all attributes of the NumPy array. Thank you all.